Today we're gonna try to understand the RGB color space. So this is gonna be something a little bit more scientific than usual, less of a development lecture, but more about analyzing data, seeing how the colors really are represented, and how can we do things with the colors, like compute distance or similarity between the colors. We will discuss different ways of doing that. And I'm going to start with the simple webcam example. So this is what we did last time, but I removed the effects part. So let's just look a little bit through the code. And we see here that we initialize a simple canvas with the given size, with this function. And then we initialize also the camera. So we talked last time that it may be possible to use also other methods, but I'm using this promise here. So this async await is something that would also work. And then once we get the information from the media device, from the camera, we assign it to a video element. And then I have here an interval where I'm drawing whatever is in that video element on the canvas. And this happens 10 times per second, or once every 100 milliseconds here. That's pretty much it. This was some helper function last time for the effects, and I think that I'm gonna need it today as well. And this was removing that that overlay that tells the title of the lesson. So yeah. Okay, so what I want to do is make another canvas next to this camera canvas, and on that one I want to plot the colors in the RGB color space. And I want that to animate at the same time as the camera images are showing, so that you can see how the colors in the RGB space change as the movement in the camera changes. So we are just gonna understand color today, and I do this because I will need to work with these concepts in the final project where we make this augmented reality piano thing. So moving towards that, and yeah, this is important to understand. So let's see. I'm gonna go to the HTML page and I'm gonna copy the canvas. So I will need a secondary canvas where we draw these axes and some data points there. And I'm gonna call it maybe color canvas. And probably I need to, yeah, I don't have the CSS file open, but if I just refresh the page now, I most likely won't see it, or it is actually on top of the camera canvas. So if I open now this debugging console, most likely, yeah, so the canvas with the camera is behind this color canvas. I could actually move this one on top, and now I can see the camera behind. So I want them to be side by side, and basically I'm gonna offset them a little bit. I don't open the CSS now, so I'm doing this inline small edit here. Okay. I'm gonna make the camera canvas be, let's say, minus 30, the minimum size of the viewport to the left, and this color canvas, I'm gonna have the same value to the right. So I don't remember exactly what their size is, but I want to be able to see both of them at the same time. Doesn't seem to work. Oh, this style is missing here. So the first one worked a little bit, but the one on the right didn't. Yeah. Okay, now I remember they were made to be 80 V min. So I think I need to put here 41 a value for this one and 41 for this one. And that means that I'm gonna see them separated and with a small space in between. So this is what I'm looking for. Right, so now that we can show the camera and this empty canvas on the right, let's prepare here a set of axes. So I'm going to do a scatter plot here of the color values, the RGB color values from the left. Let's go to the JavaScript code, and since we have two canvases, let's have color canvas here, and I think I can initialize it same size as the other canvas with the same function, but here the ID is different. And yeah, our scene here is going to be drawn on both canvases. So here we have the camera context. Let's get also the color canvas context and pass both these contexts to our draw scene function. So now our draw scene function, which is somewhere here, can draw the image here when the video is available. So this stays the same, but maybe we also, let's say, draw color space on the color context. So something like this. Now basically we can do this, show the colors on a separate canvas because both of them are referenced here. So this draw color space function is something that we need to make today, and it's going to be a scatter plot. I'm going to start with the axes. So let's try to draw some kind of axes here. Say I'm gonna still refer to it as the context. So the color space is going to be drawn just on this separate canvas. So this color context is referred to as this context from now on. And first thing that we can do is probably we should just clear everything, because I want to draw this color space as the things are moving in the camera. So I want to remove the previous color values before I draw the new ones. And now let's try to draw some lines here. So make these axes. I think that for that I'm gonna do begin path for the first axis, and let's say move to 0, 0. So the axis starts in 0, 0, and then line 2, how far do we want our axis to go? And in the RGB color space, the red, blue, and green values range from 0 to 255. So I think that we should prepare for displaying a system of axes with values between 0 and 255. So let's try line to 0 and 255. So this means a vertical axis, and stroke probably. And then I'm going to copy this, but draw the horizontal axis. So here 255 and 0. And I think that this should work somehow. Let's see. I'm gonna refresh the page, allow this, and something actually works, but it's barely visible. Let me set a line width here. Let's make it 5 pixels. Okay, now you can see this these lines here. So this is what I've been drawing so far. And you see that there are a little bit of issues here because my canvas here on the right, it's 300 pixels. And I want to display now a space with these two axes. Maybe I want to display them somehow more centered. Now it's really offset to the top left corner. And my axes are fitting in this canvas just because the canvas is big enough. But if my canvas would be maybe 200, then these tips of these axes would be outside. So I really need to consider scaling here again, scaling the canvas. And of course, you can scale these individual values, or you can use again those scaling, translating methods that we used in the past. So let's try that. I'm gonna try to do context save here, and I want to scale it so that no matter how big the canvas element is on the scene, these 255 values will mean maximum to the right and maximum to the bottom. So I'm gonna do scale, and then I need to consider the size, this global value there, and divide that by 255, I think. Let's see. If this doesn't work, then I need to recalculate this. And because this is drawn on every frame and I'm scaling the context, I should also restore the context here so that the scale doesn't happen again and again and again, basically reducing it to something strange. So let's see what happens now, refreshing this. Okay. So now the axes actually hit the right side of the canvas, the bottom side of the canvas. And just to test if this is working, let's put here 250 and 250. And now there should come a small gap here on the right. Yeah, so basically the scaling works. It works as expected here. Now, I don't know about you, but I don't like my axes being like that, like really stuck on the side of this. I would like to have some kind of margin there. A little bit of margin would be nice. And of course, the axis should be from the minimum value to the maximum value that we support. Yeah. So when we scale, we can consider scaling a bit more. So you can do that in the same function by multiplying again, or you could also consider scaling once more by, let's say, 90% of the canvas. I refresh. So now this is 90% of the canvas, but I'm still making the axes as long as necessary. So you can consider it a little bit like zooming out. And this would be okay, but let's also translate it a little bit so that this is not stuck to the side of the walls here, and center it in the screen. So I think that if this is 0.9 there, then I need to translate by 0.1 maybe. If I'm not mistaken. Okay, no, 0.1 is now basically getting it stuck on the right and on the bottom. So just half of this 1%. So this is 90%, 10%. So I need 5% offset from the left and 5% offset from the top. Yeah. So does this work now? Okay, fine. And another thing, again, practicing this scale, translate, whatever methods. I am never happy really when I'm doing some mathematical things, some mathematical plots, and I get this y-axis growing downwards. I don't know about you, but my mind is usually divided into, if I'm doing some kind of computer science things, like maybe 3D games or whatever, then the mind works like that. But if I'm making a scatter plot and I want to view some charts, I expect that axis to go up, and I just can't really look at charts the same way as programming logic. So easy way to do that is actually to scale the canvas here with a negative value, and that's it. All the things that will happen next will behave naturally, because our canvas is basically now flipped vertically. So this is what I usually mean when I say that, okay. Yeah, it flipped vertically, but now the axes are somewhere somewhere up. If you could take all this canvas here and shift it up, that's where the axes are. So I also need to translate it back down a bit. Let me write it as a second translate function here. So down by minus 255. I think this should work. Okay. It doesn't work exactly as I want it. I think this should go previous to here. Yeah, so these values change once you scale again, so I don't want to bother with this anymore now, but it's important, the order of these two operations. So yeah, basically now you have the axes going as you would expect in like math textbook here. I hope this is not too confusing. And okay, so now we are ready to draw points here. So a scatter plot usually has points, and the values of these points are going to be the color, all the different colors that are here in this canvas. So I would need the colors here. Like these colors come actually from the other canvas. So maybe we do something here like colors, get colors from, and I pass here the context on the left, the context here where I am. And these colors are going to be passed to this draw color space function to be drawn on that context there. So let's see, how do we get the colors from this context? I'm gonna make this function here because it's gonna be using this get pixel value. So we're gonna get the values of all the pixels essentially. From the context, and I want to use array notation here. So let's see how that will look like. I'm gonna try to enter a comment here, and I will return here an array. Wow. this colors array, and this array will look like this. So it will have each element will be another array, and it will be RGB alpha, for example. So each element in this array is going to be a 4-element array in order with RGB A. And RGB and A are between 0 and 255. So this is what I'm going to try to create here. By the way, if something you find confusing or you don't understand where I'm going to, you can always interrupt. So let's create this array. We're going to use that getImageData method. We used it last time to do those visual effects on the individual pixels, that pixel manipulation. So I'm going to get the value, the pixel values on the entire canvas size. And I'm going to loop through this image data elements. So get the pixels going top to down and left to right. So I'm going to name these looping variables y and x. When my keyboard wants to type. Okay. For some reason, my keyboard became completely unresponsive. And now it responds. Now it responds too much. Yeah, so this is general code that I'm writing now. Actually, it could work also with size here, but this height and width are part of the image data object, so why not use that? And the same here for the width, but with the x. So now I basically want to get the pixel value at x and y. So I have my function from last time here. Let's say pixel equal to get pixel value from the image data. So this is where that long array of groups of 4 is. So RGBA, RGBA, RGBA in a very, very long array with dimensions width times height times 4, essentially. So here, image data, x and y. And this pixel value is now in this object notation here. So I'm going to have the red, green, blue, and alpha attributes there. But I said that I want to have this more scientific feature vector notation. So in science, when you do research, this is typically called a feature vector. And the features are the red channel value, the green channel value, the blue channel value, and the alpha opacity channel value. All of the alphas, by the way, are 255 in this data because my camera doesn't support transparent pixels, and I'm not even sure which cameras do. Maybe not, maybe commercial ones don't really. I'm sure some do, but probably normal people don't have like that, unless you do some specific work with green screen or something. Okay, so I'm gonna push here each of these arrays now. So each of these array elements from there. So I'm just going to say an array with the red value, green, blue, and the alpha. So these are, okay, no semicolon needed because this push is a method and this is the argument I'm passing. So that's it. I think that this is what we need, right? And these colors are now extracted from the webcam context and sent to this draw color space function, but they are not drawn anywhere. I only have the axes here. So to draw them, I need to modify this, this function, and let's add a little bit of comments here. Vertical axis. And now we're going to do the data points. So we go through the colors that are here. Now got with the function we just wrote. And we try to draw them as points on this 2D scatter plot. So this is now a problem because we have 4-dimensional data here. We have 4-dimensional feature vectors. You could say that it's 3-dimensional because alpha doesn't bring any information in our case. My camera is not able to produce different values for that. So it doesn't matter if you use 4 dimensions or 3 dimensions, or all the processing will give the same results. But still, we have 3 dimensions, and I'm trying to plot them on a 2D canvas. So I actually can't. I have to stick to just 2 colors and like 2 channels here, maybe the red and the
Question,
green.
please.
Yeah, sure.
If I would choose to bring the A with it and crop it to half, can I make a, in quote, post myself? Can I be see-through? Would it be see-through picture? You could use it like that, maybe.
Can you repeat? So if you change all the alpha values to, let's say, 100,
to half. So can I be seen through then? Can the background be seen through me or something?
Yes, exactly.
Yeah.
That would be that would be the case.
Yeah.
Sure, you're welcome. The one problem is here I am forcing the background of these canvases to be white in this CSS definition. So if you make yourself see-through, you will just look like your brightness is going up because you see the white background behind. But if you remove the CSS attribute like this, you actually will see this gradient in the background of your image. So yeah, you would see the background as through this somehow. But yeah, but make sure that this is disabled.
There needs to be something.
Yeah, yeah. Well, it doesn't need to be. I'm making this background white because I want to know where my canvas starts and ends in the scene. But of course, I could go without. And here you can see that my bottom axis here is becoming invisible because of the gradient. So I have reasons for all of these selections and choices. But yeah. So this one also has the white background here, and If you want to be see-through and see what is in the back, remove that background. Okay, now these color values. So of course I could get the, for example, the red value. Maybe I define here so that it's clear that the X value for this data point is going to be the color of the first pixel or the ith pixel. So I'm going to go through each of the pixels here, and I'm going to get, for example, the red value from there. So the red is this first element from each pixel. And I could get to plot on the y-axis maybe the green. And I'm missing the blue. So this is now downside of not working in 3D and showing this scatter plot in 3D, but it's what I can do for now at least. So at X and Y, I need to draw a point. So this is simple. I'm going to say context begin path. And context arc. So the arc draws a circle at X and Y. Let's give it a radius, maybe let's go with 10 pixels for now, see what happens. And I want a full circle. So this arc method, I need to specify 0 and math pi multiplied by 2. So this is start angle of the circle and end angle of the circle in radians. So this math pi is 180 multiplied by 2 is 360 degrees in degrees. So converting. And let's fill this circle. So yeah, now we should be able to get something here. Let's see. Okay, doesn't seem to work. No errors. Okay, my processor is running a little bit high.
ctx.stroke.
I'm sorry?
Do we not need that stroke thing for this to appear? ctx.stroke.
Sorry, just 1 second. I need to stop some process here. It's disturbing. Okay, please say again. Please, can you ask the same question again?
No, I was saying that don't we need the stroke thing for that?
Stroke. Well, stroke would make it also have a line on the side of the circle, but the fill is just going to fill the inside of the circle. And I'm not working with colors now, so all of them will be black. Okay, just a second. Somebody is typing a message on the chat, but not on the chat right here. Okay, not related message, sorry. Yeah, stroke. It could be there. So I will show how it does. Just let's get it to work again. I suspect that maybe I'm trying to draw too many points too quickly. Let's try to reduce this canvas size to something smaller. My processor just doesn't handle it at the same time as I'm doing this let's see, I could also have some other bugs. Okay, my computer is not responding at the moment. No, I think that whatever is happening. Wow. Okay. I have a suspicion that you probably can't hear me very well.
We can hear you.
Okay, great. I'm going to lower this even more. I'm going to make it maybe 50 pixels. So notice the canvas size itself doesn't change size, but the image quality changes size because of the CSS scaling that happens. So I remind that we have this width and height scaling here. This is the images that we are working with right now. We have basically a 50 by 50 very small image here that we are working with, but actually I don't mind working with this size of image now because it's for teaching. So I think that I can work with this. Of course, I'm going to make it bigger so that you see it, and I will be blurry here, but it works. So on the right, what you see is the color values, the red and green value of each of the 50 times 50 pixels. So here on the left, we have, I guess, so how much is 50 times 50? It's 2,500. So 2,500, I think. Yeah. So 2,500 pixels, 2,500 points here on the right. But this, this radius is very big. So let's make it 2 pixels. Maybe we can distinguish the points better. And actually, the canvas on the right has no reason to be blurry. This canvas on the right can be high resolution. It can be 10 times bigger. So let's make that one here in the initialized canvas size multiplied by, let's make it by 10. In that way, we are going to have a clear picture on the right where we are showing pixel values, not this blurry mess. Let's see. Oh boy, this doesn't work. So you can see that this doesn't scale properly because I'm doing something that in programming should be avoided as much as possible. So using this global variable, I'm using this global variable anywhere, everywhere, most of the places, even though I'm initializing this color canvas with the size multiplied by 10, all the places where I'm doing things with that, like here, I'm clearing the rectangle only on this small area here, and I'm resizing the canvas relative to size, so not with size multiplied by 10 and so on. So the use of global variables like this is actually something that I wanted to talk about maybe some time ago, but yeah, so avoid that as much as possible. And I'm going to fix it by just taking the value from the context. So the context canvas width, for example, is accessible, and it will be size multiplied by 10 or whatever I decide to make the size there in the beginning, and height is same. And here the translation should also consider the canvas size when we are doing these values. So if you don't understand what I'm doing, just ask. But I'm basically removing all these global variables because now we have two different sizes and I want them to work. I hope this is enough. Let's see what we get here. Okay, so now it's basically exactly what we need. You can see crisp picture on the right. It's still a bit in slow motion on my computer. So even though this image here that we are doing the processing on is very small, it's just 50 by 50 pixels, this is quite slow to process. And let's now experiment what Abhishek was mentioning. So context stroke. I'm going to remove this fill here. So now the circles actually have this line around them, but they are empty inside. You can't really see the emptiness because the line thickness is too much. So after we draw the thick axes, let's make this smaller, maybe just the value of 1. So now I'm gonna have small width circles here. So this is what happens if you use stroke there instead of fill. And I actually kind of like it, I think. You can get an idea of the density. So you can get an idea of the density here in this area and the density in this area. So does somebody want to try to interpret this chart? Meanwhile, I think I will remove this stroke. I have a bit of a better idea how to use the fill. If you notice, the stroke actually takes more processing on my computer. At least I notice it. It lags more to draw those lines instead of the fills. And I think I could actually get even more efficient if I draw rectangles here. So small rectangles or small circles won't make a difference, but the arc method is actually using some trigonometry there, some sine, cosine inside it, inside the API of the canvas. And those methods are not easy to compute. They're actually approximated values using the Taylor series in calculus, if you have studied math deep enough. So those are not the same as drawing a circle or as drawing a rectangle where you just add the value to the width, add the value to the height. They are doing some more intense stuff. And if you do it for each of the 2,500 points here, it will add up and slow your computer. So I want to try if this works. Meanwhile, try to think what we are looking at on this axis, and let's discuss in a few minutes. So the rectangle is going to be starting at, let's make this radius 2 pixels. So this same value from here, and I'm going to say x minus radius divided by 2, y minus radius divided by 2, so that I'm starting the rectangle a little bit offset, and it will point at the center of the point, and its width and height are going to be this this radius value. Radius is not a good name. It should be size. So radius was okay here, but now this is the length of the square, actually, not the rectangle. So let's call it size. And see the difference. Wow, something very weird is happening, and I'm getting some errors here. Radius is not defined. Oh, okay. forgot this one. Okay, I don't know about you, but I'm not hearing my processor struggling very much. The points look pretty much the same as before. I can't tell that they are not circles, but it is much more efficient to draw them like this than using the arc method. So I'm gonna stick with this for now. Let me also change the colors of these axes to be more clear. So one of these axes is for the red, right? So the horizontal axis, this one is for the red value. Wow. And the vertical axis is green, I think. Yeah, so 0 and 1. And then the points, yeah, this is what I wanted to do. So instead of having the stroke, I'm gonna have a fill style of RGBA, so red, green, blue, and alpha. And the red, green, and blue are gonna be 0. So this is a black color, but the alpha, I'm gonna put it to be something transparent, maybe 0.3. This is gonna make the points see-through, so I'm still gonna get the density if many points are overlapping each other. Let's see if you get what I mean. And sorry, this should be stroke style. So stroke style for the axes. And you can see now the points, they are actually grayish in color because of this alpha, this transparency for the points. But here they turn to full black because they are just so many pixels here on the left that are near white and quite many pixels that are near black. So these are the extremes here. Yeah, let me refresh one more time and now let's talk about this. So what are we looking at here? Does somebody want to talk? Yeah.
Well, in my opinion, it's kind of obvious.
Okay, obvious.
Like what I mean is the concentration that's showing near what the pixels gathering around the near white are because green and red and white is usually where red, green and blue are in 255 or near 255. So I would say at the top, the pixels that are gathering at the top that are concentrated region is more like for the white wall behind you or something, and then the black is from your hair, and that's near the origin kind of thing. The others that are gathered are, I would say, for your skin because it's a little bit creamy. So
it's a little bit red, this
yeah,
these points probably.
Mm-hmm.
Yeah, let's see what happens if I move the camera up like this. This is just an empty wall now.
Yeah.
And now I'm putting my red hand, reddish hand in the screen. Okay, I also have a banana. So what happens with the banana? Because it actually
yellow.
What is
because yellow is a combination of red and green. I think that's why it's showing linear.
So it's almost the same as white because white is combination of red, green, and blue, which we just cannot represent here.
Yeah.
So let's see what happens with my blue color. You can see
there
are some things there, some points appearing there, but we don't represent blue at all here. So what this actually is low values of green and red.
Yeah.
It's almost black if you consider this 2D axis representation there. And if I'm gonna put this green cloth here, then this is now going very high up into the green, but this green is just not green. It's kind of yellowish because of the light here in the room. So if I would have pure green, it should be here, sticking to this value. By the way, yeah, this green that I'm drawing the axis is not pure green. Even though I write here green, this is pure green. So the color label that HTML recognizes is not necessarily the same that you would expect. So if I would have something exactly this color, then all my points would be here. And if I would have something that is pure red, it would be here. But you see that it's not like that. And your mind is very different from what the computer sees. So when you show it this, I'm telling you it's green, you probably agree with me that it's green. It's greenish, it's more green than red, definitely, but there are a lot of red values in this signal still coming from there. So this is what makes some parts of image processing really difficult. And this is red. You can definitely see now something happening in the image there, like really going towards red. So even though I don't have a good green here, I do have a powerful red, very close to pure red. And now if I move this closer, then more values in that red area are appearing there. So that's kind of nice. But many things change. So you can see light reflecting from this. It's not as easy as telling it to tell the computer select all red pixels. You can't expect it to know what are all the red values there, and you may end up with something like my face. Maybe you think it's red, but I don't think my face is red. So computer thinks that there is some reddish stuff in the scene there. And yeah, so color perception and the way that computers understand colors and how different one color is from the other, this is how the computer understands it. Now let's play a little bit more because I think we have time. I'm going to replace this red with no, I'm going to replace the green with blue. So I'm going to replace it like that. And here, yeah. So now I'm showing the other two axes, and let's see if they are different. Now, you notice that it actually looks very similar to the previous one, right? We have, again, that cluster on the top there is very well defined because we have a lot of white here, and white means high values of blue, green, and red. And then we have some darker cluster here, which is for the black things. My hair, my shirt is actually brown, but my webcam is not that great. And yeah, Anyway, so what happens now with the green? You can see that the green is not appearing anywhere anymore at this time, but the red is impacted because I told you that computer doesn't think this is green. It's a lot of yellow here, maybe coming from the light at the top, or not the correct hue that it expects. But now the blue is acting up. So you can see all those points on the top part of the chart there. They are because of the blue pixels that I added now. Before we were not able to show blue, but now we can, and I can even, yeah. But even though this cup is blue, it's as blue as it can get. All of these reflections in it and shadows and whatever makes this happen in the colors there. So really interesting patterns and effects coming from that. And this should indicate to you just how hard it is to do some kind of image processing. So your expectation is that this should be identified as the only blue object in the scene, but all these things are affecting that. So it's not an easy task. Okay, if you have more questions, ask now. Otherwise, I'm gonna move to try to visualize 3 dimensions on the 2D canvas. So I'm gonna make some simple math to draw another axis for the green axis, and I'm gonna just make it come somewhere here, maybe towards us, and I'm gonna try to draw the points in this kind of 3D space to see if we can understand this a little better. And I'm also going to teach a little bit about how to fake the 3D on a 2D canvas, because I don't want to teach the WebGL canvas context. It's just too much. I think this alone is enough content. So, any more questions about this? Is this kind of understood what we are looking at? And by the way, this kind of line that you can kind of see that the data here forms this kind of diagonal. It's quite obvious, and that's very common in organic images like me. Like, this is not white here. This is a combination of many gray values, and maybe it spans from dark somewhere here to light somewhere here. It's something that your mind and your eyes don't even notice. They are so subtle changes, but they do make this many different gray values just by looking at the color values there. So kind of blowing the mind how different this is to the computer. But if you look at this like a human looks at this, they are gonna say it's the same color. But it's not. It's there is a very strong shadow here behind my head, and if you really look at the color values. So yeah, and everything is noisy here because of noise. So even if I don't move, I can't really not move, but I could show you my wall there in the ceiling. The noise comes from bad sensors in the camera. My camera is not that great. The light in my room flickers. We have alternating current. You know that the alternating current works so that the light actually pulses. It pulses very quickly at a fast frequency, and that can impact this amount of noise that we are experiencing there. So this is now me kind of teaching you a little bit about the science part, but I think it's good knowledge to have, and in some of your projects you will need to use this. Okay, if no more questions, then let's try now to draw this third axis. So, and see how that would work. So drawing 3D in a 2D space. And this is going to be also some important lesson about data visualization. So let's say axis towards us. Maybe we call it like that if it makes sense. So an axis that comes in our direction, and that's going to be green. But I'm going to use the RGB notation to have 0 red, 255 green, and 0 blue. Now, it starts at 0, 0, so all the axes start there. But I want to be able to draw this at an angle. So maybe I'm going to say, maybe I'm going to call this as some kind of Z offset. A value here, and I'm going to say, okay, minus 50, minus 50. So 50 to the left, 50 to the bottom, and let's just see what we get here. Minus 50, minus 50, and here I'm going to put the Z offset minus 50 and Z offset minus 50. I could have written these here, but I want it to be clear what it means, like instead of all these hard-coded values everywhere. Like 255, you should know what it means. The best would be to define somewhere this and use it as a constant, but I'm not that picky with the code. So yeah, but here, minus 50, what is minus 50? This could mean anything. So this is the type of constant that would need some kind of definition, and that's what I'm trying to do. So a lesson about code naming conventions. Yeah. So let's say refreshing this, nothing works. What? It should draw another line here, I think. Am I doing some mistake? So, oh, minus 50, 50. Oops. Yeah, so minus 50, minus 50. Otherwise, it would have been minus 50.
Should it
50,
not be 50
yeah.
minus 50?
I'm sorry?
Should it not be 50 minus 50? Like the x coordinate,
Well,
shouldn't it be positive?
Then it's gonna go this direction, right? To the right here. I think that you can design your axis the way any way you want. So you could plot it like this, but when I'm drawing things, okay, I have some idea. Keep it in mind. So if you like to draw your axis like this, so that it goes like that, I have an idea. Yeah, but for now, I prefer to have this visualization here. So the thing is going somewhere here, but it's going off screen again. So I need to work again with my scaling here to make it fit nicely. So maybe we zoom out even more. Let's see. Okay, but now also should translate this a little bit to the right. So maybe translate here. Let's put maybe 35 horizontally. Okay, I think it's lucky guess and good enough. So I'm still looking at a 2D chart, right? All these values are still the red and blue axis. You can imagine that all of these values are stuck to the back wall, formed of this blue and red axis here. So now what I want to do is I want to maybe bring those points in front if they have green value. And if they have maximum amount of green, then each point from here should be translated by minus 50, -50 in the axis direction. So that's how what I want to mimic now, this effect of 3D here. But if the green is maybe half amount, then it's only going to be translated by half of this axis value. So 25, 25 in the axis direction. Okay, my computer. Okay, yeah, it behaves again. So do you understand what I'm trying to do? I'm trying to somehow replicate a 3D effect on this 2D canvas by moving the points in the direction of this whatever axis we have here. So how do we do that? This Z offset value that is going to be important, and the X and Y values that we are computing based on the red and blue values need to be translated based on this Z offset value. So this one is going to be the X multiplied by how much the green is telling us. So this is the one here is for green, but divided by 255. So I'm normalizing here the green value to be between 0 and 1 essentially. And then I'm telling that from this Z offset, like this -50 in this case, multiply it by how much green there is. If it's going to be 1, it's going to be -50 here. If the green value is 120 something, so half of this, then this is going to be normalized to be 0.5, and this offset is going to be -25. So yeah, I hope this is somewhat clear. And I'm going to do the same for the Y value. So the same thing. And here, let's say green. Index 1. So modifying these X and Y values to somehow give the impression that they are affected by the green axis. That's the whole thing that we are doing here. And the result is maybe affected a little bit. This should be white, so you can kind of think of it as not glued to the back wall anymore, but maybe coming like that this diagonal here is coming to the opposite corner of this cube that we have. So it kind of can look at 3D-ish if you are looking for it. But it's not really possible to say something is 3D just by looking at it from one angle. That's why many, most everything that supports 3D displaying, like if you watch 3D charts or if you play 3D games, they allow the user to change the camera angle. And that's what gives the understanding of 3D. And even more than that, the biggest understanding comes from the user that is playing with the camera angle. So because when the person is maybe moving the mouse to control the camera angle, that user has the expectation of what will happen when he tries to rotate something. So other people that are watching don't have this expectation. So this is something very difficult to think about, human-computer interaction here. Of course, if this object would be constantly rotating, constantly spinning, then people watching it could understand the 3D because they understand this constant behavior, this constant change in it. And this is what I want to do now based on Lydia's comment. I'm not gonna rotate all these axes. I'm not gonna make too much trigonometry here, but I'm gonna decide the angle of this axis through code, and I'm gonna make it change, simulating a little bit kind of skewed 3D effect. And then we should understand how this third axis is affecting the 3D scatter plot now. So this, I'm not sure how this would go, but let's just see. I'm gonna take this Z offset value. I'm gonna put it here up as a global variable. And I think I'm gonna need also a frame count. So let's say that we start at frame 0, and every time we draw the scene, we increment this frame count. And here, our Z offset, the X value of the Z offset, I'm gonna say maybe something like this. So it's gonna depend on the frame value. It's gonna be affected by the frame value, but because the sine function, if you know your math, is a periodical function that increases from 0 to 1, then goes down to -1, then goes back up to +1. This will eventually stabilize around the initial value of -50 that we give it. A little bit complex math here, but I don't want to teach you this math necessarily, so don't be too scared. I want to just see if this will improve our visual understanding of the color space. So let's see what happens. Okay, before I press allow on the camera, you can see that that something is happening with this axis. It is now being controlled by the frame count and by this sign. And actually, I made a mistake when I explained it, because the sign starts at 0, so it's going to be biased towards positive values. Cosine would probably be better choice, but I don't want to go into math. So let's see what we have here. You can see it's not really a 3D rotation. It's not a 3D rotation, but it almost appears to be like that. A true 3D rotation would need me to compute the new angles also for the red axis, at least if we do a rotation around the blue axis. But I don't want to do that much work. I think that this is good enough, but maybe we start with the value of -100 here, and then I don't have to bother with this cosine stuff. So now my axis goes also a little bit in this other direction, and you can see that these X and Y and Z points, they are affected by it. So if we don't affect them here by this Z, by this green amount here, if we don't do this thing in the code, then those values should still stay stuck to the back wall, and it doesn't depend anymore at all on the green axis. So I'm actually quite happy with this, and I've never done this before. It's not a true rotation, but it almost tricks your mind into thinking that it is. It's simple to implement, and now you can get that, okay, this value is actually opposite corner of this cube that you see the 3 axes coming out of it. Okay, great. So I like this. I want to improve it a little more. Let me try. I'm going to make the size start at 0 at 2, but I want the size to also be bigger as it is closer. I don't know if this is going to improve it or not, but the closer the object is from your viewpoint, the bigger this small dot should appear to be. So I could say the size equals 2 plus, and again, the green color value. So a bigger value of this green is going to mean bigger points, essentially. And again, taking a value between 0 and 1. And this would mean that my front pixel is going to be just 1 pixel bigger, this front rectangle. So it's, maybe I could multiply this by something to give it a bigger scale. Let's see if this works in any way, if it helps or not. So this is experimenting and trying to come up with some better interface. So you can see a little bit that these points here are bigger than the ones close to this far corner. I actually like this effect. I think I'm gonna keep it. How about we don't make them black, but how about what would happen if we actually keep the real color of the point? So showing it by its true color, would this look like anything better than what we have at the moment? So I'm going to take the red value here. Then I'm going to take the green value. And finally, I'm going to take the blue value. And I'm going to keep the transparency here 0.3. So I still want to see this density if possible. And does this give us a better visualization? Let's see. Okay. You can kind of see my skin tone here. And the pixel values from the cup. Let me try to remove the opacity of the points. Maybe this is better, or let's see. So now those points looked a little brighter than they look in the main image. So now when you see those blue pixels coming there, blue data points coming there, they have exactly the same color as the cup has, as the pixels that are forming the cup. So I don't know, I think that experimenting like this makes it clear what's happening, a little bit clearer. I also think that this chart doesn't consider the ordering, and that is a problem. Like now, we are getting some reddish pixels in front of the green pixel mass. So similar what we did in our train view, we should actually sort these points so that the smaller points are being drawn first, and then the bigger points are being drawn on top of this. So it's relatively easy to do, I think. I need to do it here. So colors, sort. Okay, I've been talking way too much, and I think that I'm a bit worried. Is my microphone still working, and is everything okay? And am I going too deep in this?
Yeah, we can hear you.
Okay, I think
so
you...
there is nothing wrong with the voice, and the frame rate is choppy as usual.
Okay, sorry about that.
Go on, please. This is interesting.
Okay, great. So I think some of you were saying at some point things like this course is too easy. So maybe now it's getting more interesting also for you guys. well, I don't know what else I want to make. Now I fixed this problem, so the green is appearing always in front of the other values because it should be in front. So this sorting helped. Yeah, so now basically I'm preparing the stage for what I want to do in that piano. In the simplest way that I know how to implement that would be if I use some kind of colored marker, some kind of colored object that I could maybe use to press the keys on the screen. And if you have seen the videos I pointed to you in the exercises, yeah, I don't have marker here, and I can't walk very fast, so I'm not gonna go get it. If you've seen those, you basically understand where I'm going at. So that would be the easiest way to make this piano system, to have some kind of object that I'm using to detect its position in this image on the left, but based on the color value on the right. And the color value is tricky. I can't just tell the computer, look for color blue, because which blue? There are so many blues there on the right now that I would have to make a kind of a lookup table for all of them and say this is blue and this is blue and this is blue. So all of them are part of the marker. Or I could use properties of this Euclidean space on the right and define a single value for blue and say that nearby values in this 3D space are going to be accepted. So in this lesson today, I just wanted to tell you that it's not easy. You can't just say, look for a blue value. You need to look for a range of blue values. And this RGB space is just a simple introduction and something that I think you can properly understand. But there are other color spaces as well. So the blue is actually not the best for our purpose. And this RGB color space, what we have here, is not necessarily the best here because human perception and these values defined here in the RGB are not the same. There is a long thing to discuss about this here, and I'm not going to go deep into, but think about a point that is pure green, so the green value from here, a point that is pure blue, and a point that is pure red. In this RGB space, the red is the same distance from the blue is the same distance from the green, and the green is the same distance from the red. But from human color perception, and we are making the app for humans essentially, many apps are for humans, and if I want to say to the computer, this is blue, then I would like this blue to maybe cluster better there, not like it's doing now. And if I ask you, how similar is green to blue, and how similar is blue to red, I'm probably gonna get different values. So human color perception, that's why we have the color department. So here at the university, we have a lot of people doing color research. There is a lot of stuff going on there, and I'm just scratching the surface here. So if you're interested in these kind of things, different color spaces, this hue saturation value, this HSV color space is totally different from this. It has a value for the hue, a value for the saturation, so how much color it has, and a value for the luminosity. The last one, value, I think, stands for luminosity. This is another color space. One that is very suitable for human perception is called the LAB color space. It's something that you can study if you want. And if you do the conversion from this RGB color space into these other color spaces, you will get a different configuration of points there. And in some of them, these blue values maybe are going to form a tighter, more compact cluster that could be processed and detected in the code. So basically, converting to another color space could be a way for the computer to understand the color differences like humans do. I'm not gonna experiment with more of these. Last year I did do something, but if you search online, you will find, even in JavaScript, converters from RGB to HSV, for example. I'm pretty sure you can find to this LAB also. If you're interested in learning more about these, then definitely you can search, but I don't think that I will need. Let's see. So, okay, we still have 2 minutes. Hopefully this doesn't take too long to implement. I'm gonna try to convert my colors from one space to another, and let's see if this works. So my color is an array. You can ask other questions meanwhile. So I'm now fitting the function that I copied to the data types that we are used to work with. So I'm using these array values. Also note here, this value ranges from 0 to 360, 100, 100. So we actually don't have the values between 0 and 255 anymore. Some strange things happening, some math that you would need to understand. And where we get our colors, get color from, I'm not gonna push it like this. I'm gonna push it after I convert it to HSV. And yeah, let's see. Did this change it already, or is it full of bugs? Okay, I'm gonna remove the coloring. So yeah, this worked much better than I thought. I'm gonna remove this coloring here of the points because now the coloring is meaningless. It's not anymore the RGB axis, it's the HSV axis. And yeah, I'm just gonna make them black, these pixel values. And I'm gonna finish in a couple of minutes, please wait. And these axes here, I don't need to make them colored because they mean something else. The first one is gonna be, okay, let's make the first one blue because the first one is gonna be the hue. The hue value and saturation is on the X. So the hue is the color, and I'm making it blue so that it's still colored. Kind of gives the idea, but yeah, let's see. So, okay, so hue, no, sorry, this was a mistake. This is not the first axis. It's not the horizontal axis, which is the first one. It should be, this should be black, this should be blue. This should be black again. Yeah, so this is the same thing, but displayed in a different way. You can see now the blue appearing a different pattern. So than previously. This doesn't look at all like what we were looking at previously, but it's still a bijective mapping between the HSV and the RGB color space. So see now, this green is actually forming a very deep cluster there. Previously, it was kind of all over the place. And yeah, I don't know what else I have here. But anyway, I'm going to revert this to the RGB color space in the final code example. Or maybe I'm going to keep both of these, but I'm going to do this edit off screen. So that's it for today, and you can check the code later. If you still have questions, then please ask. I hope this is not too scary. Yeah, and here you can see this difference for the hue going to 360. So it actually goes off from our axis values here to the right, and vertically and towards us, it only goes to 100 because that's how the saturation and the luminosity is scaled from 0 to 100% basically. So our axes here would need to, we would need to work on these axes to make it look nicer maybe. I could edit this code a little bit before I publish it, so check it out afterwards. So that's it. Any questions?
Thank you. Bye. No questions.
Thank you.
Okay.
Thank you.